Okay, you guys, we are live. Well, I mean, I don't care if you are quiet, but you don't need to be quite so rowdy. Okay, so what we're talking about are these boys. We're talking about these things we already know, these common properties that we already know that you can use to prove that things are congruent. Okay? So if you look at this triangle and this triangle, they have this side the same. HJ is the same. It's in both of them, right? So as we could say, I know this sounds so redundant, but we could say, oh look, HJ is congruent to HJ, right? And what's our reason? Or our reason is the reflexive property, because it's the same in both. It's a reflection from one to the other. Okay? If you look at this one, you guys know this. I don't have to tell you this. If you have an angle here and an angle here, and they're made by these two lines crossing, those two angles are congruent to each other. So in this case, we could say that angle BCA is congruent to angle DCA because they are vertical angles. So our reason there would just be vertical angles. Right? Y'all with me so far? So far, so good? Okay. So if we look at this one, if you have this diagram right here, and this is marked, and this is marked. Now tell me what that marking means. That means 90 degrees. Guess what we know about angles that are 90 degrees? If they're both 90 degrees, what conclusion can you draw about those two angles? They're congruent. So we could say angle B is congruent to angle E. How do we know? Because right angles are congruent. Right? And you could use you could say definition of right angles if you wanted to. I'm abbreviating just to make it faster. And you can abbreviate. I'm okay with that. You can abbreviate. Okay? Now, if you have something like this, where you have this diagram, what does this and this indicate? They're little arrows. If they were little marks, they would indicate congruency. But they're little arrows. Like this is an arrow. And this is an arrow. What does that mean, those little arrows? No. I mean, good try, but they are parallel. When you have arrows on lines, that indicates they're parallel to each other. Okay? So, now, if this line, hey, some of y'all are having conversations and you need to be listening. All right? When I'm teaching, you're not talking to each other. You're talking to me, not to each other. So, if I have this line here, and I have this line here, and they're parallel, and then this is a transversal that crosses it, what would this angle and this angle be called? What angle relationship do they have? What are they to each other? Alternate interior angles, right? So they are alternate interior angles. And what do we know about alternate interior angles? They are what? Congruent. So I could say that this angle here, FGJ, so I could say, y'all hang on just a second. I got to make an adjustment because I've got a stack of papers underneath this paper right where I need to write. Can you hold it until I get through? Or at least for a few minutes? If you can hold it for a little bit, that would be awesome. If you got to go, I understand. Sometimes you got to go, you got to go. Okay? Okay, so we could say that this angle, FGJ, angle FGJ, and Bo, if it gets to the point where you just got to go, just get to go. Okay? You have my permission in advance. FGJ is congruent to GJH, angle GJH. And how do we know? Because they are alternate interior angles. That would be our reason. Do y'all see how that works? How we're given the reason based on something we know that isn't triangle related, but is something that we know already. Y'all see how this all fits together? It all goes together. Okay? We haven't talked about segment bisectors, but we've talked about the word bisector. And what does the word bisector mean? It means two. Bi means two. But when we say bisector, what does that mean? What, in anything, if it's an angle bisector, segment bisector, perpendicular bisector, what's it doing? It's splitting something into two equal parts. Anytime you see the word bisector, that's cutting something into two equal parts. So if it's called a segment bisector, what's it cutting into two equal parts? A segment, right? So if I told you that T, line T right here, was a segment bisector to TR, then what does that tell you about TQ and QR? They're congruent because a bisector cuts it into two equal parts. So if that's bisecting those, then we could say that TQ is congruent to QR because of a definition of a segment bisector. Because segment bisector cuts something in half into two equal parts. See how it works? Okay. Now, you'll definitely know what a midpoint is. What's a midpoint? A point in the middle. If you have a line or a segment, and you have a point that is in the middle, midpoint, right? What does it create? You've got a segment with a point in the middle. What does it create? Two congruent segments. So if I tell you J is a midpoint, right there. J is a midpoint. What segments are congruent because J is a midpoint? So KJ is congruent to JI because of the definition of a midpoint, right? Y'all with me so far? Y'all? Okay. What about angle bisector? What does angle bisector mean? What did we already talk about bisector mean? What does bisector mean? Split into two. So what is an angle bisector? What does it do? Splits an angle into two equal parts, right? So if I tell you DH is an angle bisector, that means it creates this and this congruent angle. So I could say that angle BDH is congruent to angle FDH because of the definition of an angle bisector. Y'all following? Okay. What is a perpendicular bisector? Well, what's the word bisector means? Split something in two. What does perpendicular mean? What? You're confusing perpendicular and parallel. Perpendicular means they cross at 90 degrees. Hey, tomorrow when y'all come in, I want y'all to sit somewhere other than where y'all are sitting. You cannot sit by the people you're sitting by right now. Y'all gotta move around. Because y'all have got to where y'all don't even pay me no attention. Y'all just sitting back there having I-ho conversation. I know there are a few of you that are paying attention, but for the most part, most of y'all just sitting back there, just chit-chatting, having a good old time, not paying me no attention. So I'm going to give you a chance to move yourself. And then if that doesn't work, I'm going to move you. Okay? I'm going to put you somewhere that I think you'll pay better attention. So this is your opportunity for you to make a good choice. Y'all hear me? Okay. All right. I may, if y'all don't start paying attention during class, this period, I may make you just get up and do it right now. So you better get it together. I don't sit up here and talk because I like to hear myself. That's not why I'm up here. I mean, I wouldn't project my voice if I just wanted to hear myself. I'm up here because y'all need this content. I'm doing the best I can to try to give you the information you need. And you need to attempt to listen to me. Okay. Perpendicular crosses at 90 degrees. That's what perpendicular means. So a perpendicular bisector crosses at 90 degrees and cuts something in half. Now, what that tells us is two things. Number one, it gives us 90-degree angles, right? And what did we learn earlier about if we know they're 90-degree angles? What do we know about them? They're congruent because they're 90-degree angles, right? Number two, it cuts this side in half so that you have two equal parts. So knowing that something's a perpendicular bisector gives you two pieces of information. You know that you have two angles that are congruent, these 90-degree angles, and you know you have two sides that are congruent in these two triangles because it's a bisector. Bisector cuts things in half. Okay? We only have one more, and then I've got a little bit of talk, and then I'm going to give you some problems to work on. Okay. If I tell you that A is congruent to D and B is congruent to E, but I don't tell you about these two, I don't say anything about them, what conclusion can you draw about those two angles I did not tell you anything about? They have to be congruent. This is called the third angle theorem because there's only one option for that third angle, right? There's only one thing it could be. In any triangle, if we know that A and D are congruent, B and E are congruent, then this angle and this angle have to be congruent because of the third angle theorem. Y'all with me? Okay, flip this paper over because I'm going to have you write a little bit of information on the back of it, okay? All right. Now, what are our four triangle congruence theorems that we were talking about? If you didn't get this paper, get up and get it right now. Go. I see people who don't have it. Y'all get up and go get it. Even though I asked before class if you got it. You better grab Bo one too, Kanan, because I know he didn't get it either. Okay, we have four triangle congruence theorems. We actually have five, but we're not going to worry about HL right now because it only deals with right triangles, okay? So right now we're just going to deal with four. What are those four triangle congruence theorems we learned about last week? SAS, side, angle, side, okay? Angle, angle, side, yes? Side, side, side. I heard this one first, but then what'd you say? We already have side angle. Side angle angle is the same as angle angle side. Those are the same. But yes, that does work, but it's the same as this one. What? Side side angle doesn't work. Remember that's ass backwards. Well, we need three. Only 3 parts. What'd you say, Caitlin? Yeah, angle, side, angle. Angle, side, angle. Okay? Now, remember, we have a couple that don't work. Angle, angle, angle does not work. That works for triangles to be similar but not congruent. And then angle, side, side doesn't work at all. Okay? Or its backwards component, side-side angle. Those two do not work, okay? Now, anytime that you are trying to prove that two triangles are congruent, and you're writing a proof, so you've got a proof where this side is a statement, and this side is a reason. And you're trying to prove that one triangle is congruent to the other triangle. Your final part down here, your final thing, your final statement and reason will be, if that's all you're doing is proving the two triangles are congruent, if that's all I'm asking you to do, then you will, and I'm going to make some crap up, okay? But you're going to say like, triangle 1 is congruent to triangle 2. And then you're going to give one of these reasons. It's either going to be because side angle side, or angle angle side, or side side side, or angle side angle. One of those four things will be right there. Now, for you to prove that those are congruent based on one of those, you have to tell me those three pieces are congruent to each other. So above that, before you get to this last final statement where you're proving it, you should have at least three statements. You could have more, but you have to have three. Now, why do you have to have three? Because you got to know 3 parts of this triangle are congruent to 3 parts of this triangle. Now, that's either going to be, oh, hey, this side is congruent to this side. This angle is congruent to this angle. This side's congruent to this side. Or something like that, right? But whatever it is here has to support your whatever you use. So if you tell me side, side, side is the reason they're congruent, then you should say this side's congruent to this side, this side's congruent to this side, this side's congruent to this side. Y'all follow what I'm saying? Like this should be sides are congruent, sides are congruent, sides are congruent, side, side, side. Right? If you tell me that this side's congruent, these angles are congruent, and this side's congruent, and then you tell me side, 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 that's wrong. Because your proof doesn't back up what you say. Y'all see what I'm saying? Also, you can't just write the given and then say they're congruent. Ever. Like very rarely. Every once in a while you'll be able to use just your given information. But most of the time you're going to have to do a little figuring, a little calculating, a little, oh look, I know this because of this. And that's going to have to go in there and you're going to have a reason. Okay? Now, can you have more than 3 statements before this? Yes. You absolutely can. But you have to have at least 3. Why do you have to have 3? Because you have to be telling me these 3 things are true before you can tell me that that's true. Y'all see what I'm saying? On your papers I was looking at on Friday, a lot of you just went in and wrote down, you had a diagram. So you have this diagram and you've got A, B, C, D, E, F, right? And it told you this was, let me change this diagram, hang on. Let's say you have this. Okay? And let's say I told you this was congruent to this and this is congruent to that. Let's pretend like this was a proof, okay? And you know that AB is congruent to AD. And how do we know that? It's given. Right? And then you know that BC is congruent to CD. And how do we know that? It's given. Right? That information is given. Well, what a lot of you did, was you'd be like, oh, so I know these sides are congruent, so I'm just going to say side, 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 and you would just go into, oh, triangles are congruent. That doesn't mean the triangles are congruent. We have to say that one more side is congruent. Fortunately, in this case, we do know that they're congruent. What do we know about AC? They share it. If they share it, it's the same in both of them. Yes, sir. What is this property right here? What's this called? When they share it. Starts with an R? Ends with efflexive. That's a reflexive property. Now, they have sides congruent, sides congruent, sides congruent. What makes them congruent? Side, side, side. Y'all with me? Does that make sense? Okay, I've got a paper I'm going to give you that has 4 problems. Actually, could I get somebody to grab that paper and pass them out for me so I can finish this up and post it? It is laying on my desk.